Okay, we're back to work on our measures of central tendency and measures of spread for grouped data. All right, we're going to base it all entirely around this data set here and the groupings that we've already done for height. Okay, what I did was I just sort of snuck myself up over around here, and I copied and pasted the frequencies 1, 2, 6, 6, 3, 1, 1. For each of the groupings. You do need to do that first. You have to do a frequency first if you're going to do group stats, because all of these calculations are based on that. So there's going to be a lot of sums in here too, so those are very important stats to do along with it. And of course then we're going to be using a lot of our formulas. There are no formulas in the f and x sort of function here for grouped data because the grouping is variable. So we're going to do it all just as we would have done it on paper. So for the mean, grouped mean, it's going to be the frequency times the midpoint. So I have the midpoints calculated. It's just a midpoint between 139 and 149, 144.5, and the same for the rest of these. Okay, there are my midpoints for all of them. The midpoint is basically a way in which we can quantify a grouping that's a range. Okay, we take the middle value of that value. So for the mean, it's the summation of the midpoint, mi, times the frequency, summation of the frequency, fi times mi. It doesn't matter the order that you do it in. I'm just trying to be consistent with the formula. Here I'm going to be making a lot of my own formulas. Okay, so I go equals, and I want to do the frequency, boom, times, and for times you use a star. So second function or shift 8. And then, so frequency times my midpoint. Okay, and I just go enter. And the nice thing is that I can slide all of them and they all move with each other. So again, frequency 2 times 154.5 is going to be 309. 6 times 164.5 is 987. 6 times 174.5, 1047. 3 times 184.5 is 5, and so on, and so on, and so on. Okay? Now we need the sum of this value. And the reason why we need the sum of this value, I mean, go to f of x if we want to, and we can find sum. Okay, and we choose sum, and oops. We take sum, we insert the function, okay, and then we just highlight what it is we want it to add up, okay? Because again, the formula is the summation of fi mi, that's the summation of fi mi divided by n, or the frequency, the summation of the frequency. Okay, so we should do a summation of the frequency here as well. Okay, so again, I go ahead and I choose sum. I insert the function, and I take it for the data set that I'm dealing with here, and then I'm done. Okay, now if I want to do the mean, I type in the mean here, and I use my summations. Okay, so the mean is going to be the summation of, so I go equals, the summation of fi mi, 3440, divided by the frequency, the summation of the frequency, which is 20. Oops, sorry, that divided by the 20 gives me my mean, 172. Okay, and that's my group mean. Okay, now for my variance, it's going to be a lot more complicated, and then for my standard deviation, for both of those, we're going to treat this as a sample. Okay, because it is 20 individuals, and if it was our class, it would be at 29 individuals, so we know for sure that it's a sample because it's not even the whole class. Okay, but in order to do the grouped mean, it's much more, variance and standard deviation, it's much more complicated. Okay, first of all, we have to do a deviation. So we go mi, the midpoint, minus my mean. Okay, I'll make it a capital X because I can't do an X bar on here. Okay, and so really what I have to do is I have to take my particular frequency, or my midpoint. So I create my formula and I go equals, and I take my midpoint, 144, minus my mean, which is 172. Okay, and then I press enter. Now before I press enter, I'm going to slide this formula and do it for all of these particular values. So for 144.5, for 154.5, 164.5, 174.5, and so on and so on and so on. But I want these guys to slide okay, along with the C values, but I don't want the B50 to change. So again, I have to keep the B50 consistent. So I put a $ in front of the B and a $ in front of the 50, and that gives me an absolute cell referencing, keeping this 172, this red value, the same. Okay? And you can see it's 27 below. 72 minus 144.5 is 27. And then what I do is I drag it and replicate that formula. Okay? Now, I don't want to go ahead and add this all up. If I do add this all up, I'm not necessarily going to get to 0. Okay? So keep that idea in mind. For grouped means the deviation should not total to 0 necessarily. And certainly the deviation weighted by the frequency. So anyway, so the formula requires us to go to do on the numerator of the variance and the numerator of the square root of the variance, which is the standard deviation. The numerator is a summation of fi times the bracketed x minus x bar, close bracketed squared. Okay, so there's a lot of stuff going on. So I have to do the midpoint minus the mean. Okay, then what I have to do is I have to go the midpoint minus the mean. Oops, call it mi. Mi minus my mean. Again, I'm using a capital X for it. Close my bracket, and then I'm going to put hat 2, which is to the power of 2, which means I need to square it all. So I need to take this value here, and I need to square it in here. So I go equals, and I can make my formula two ways. I can either take this and multiply it by itself, or I can square it. Okay, so I'm going to go this, and then you use a little hat, which is above the number 6, and then 2. And that's going to square it. Okay? And 25 squared is 625. So 27 squared is 756.25 is accurate. And then for that, okay, because I'm taking this value and I'm squaring it, I want to do the same thing here, same thing here, same thing here. So all I do is I drag my formula and I get all those values. Now I still don't want to sum this up because I also have to multiply it by the frequency. Okay, so I do the deviation, what's inside the brackets first, the midpoint minus the mean. Then I square it, moving outside of the brackets, just to the squaring. Okay, and then I multiply it by the frequency. And then I add it up. So I've got deviation. I've got deviation squared. Now I'm going to have the frequency, Fi, times Mi minus, midpoint minus the mean, again, hat 2 or squared. Okay, so I'm building. I'm doing the deviation, which is inside the bracket. I'm doing the deviation squared, which is sort of this component here. And now I'm doing Fi times the deviation squared. So what do? I create my formula. I go equals, and I take my frequency all the way over here, 1, in this case D40, and then multiply again, star, okay, is multiply. And I want to multiply it by this guy because it's the Fi times this whole thing. Okay, so there's my Fi, D40. And then I click here, the red one, which is G40, and I press enter, and there it is. And of course, it's 1 times 756.25, which is 756.25. For the rest of them, they have different frequencies, so different values are going to appear. And so I drag it all the way down, and each one of these is going to go 2 times 306.25, which is 612. 6 times 56.25, which is 337. 6 times 6.25, which is 37.5. And then again, of course, 1 times 506 is 506, and 1 times 1056 is 1056. Okay, now I'm at the point where I can sum it all up. Okay, this is going to be the numerator of your variance. Okay, and then the numerator of your standard deviation after we square root it, or before we square root it. So I want to sum this up here, so I go sum, pick my sum function, I insert it, and I say I want to add up all of these guys. I want to sum up Fi times Mi minus x bar squared. Okay? And I press done, and it's going to give me 3775. Okay? Now for my variance, what I want to do is I want to go equals, and I want to take this value, that's the numerator, divided by my denominator, which is going to be this. I should probably bracket it. And then go the 20 minus 1, which I could just go 20 minus 1 and put in a 19 if I wanted to. But if I want to put in a formula, there it is. Okay, and that's 198.684. That's the variance. Okay, so it's about 3,700, almost 3,800 divided by 20, which is fairly accurate. Instead of course being divided by 20, it's divided by 19. So it's off by a little bit. Okay, because 20 times 198.6 or 20 times 20 is going to be about 4,000. But if you take one away, yep, we're going to be really close to about 3,800. So that's my variance. Again, you have to divide by n minus 1 because we're treating this as a sample. Okay, and for my standard deviation, all I have to do is go equals, and I want to take this and square root it. Now, how do I square root it? I go to the power of 0.5. I don't know if you remember from grade 11 math, but a square root is to the power of a half. Okay, or 0.5. I'm going to make it 0.5 for simplicity's sake. You press enter, it's going to square root roughly 200. The square root of roughly 200 should be about 14. This is going to be a little bit more than 14. Okay, so it's 14.09. All right, so that's going to be our standard deviation. Okay, so we've got our grouped mean, grouped standard deviation. We go back and look at it. It's not too terribly different. Okay, here we've got a mean of 173. For grouped, we have 172. For our standard deviation, we've got a 12.4. For here, we've got a 14.09. Okay, we treated them both as samples. Okay, but here, of course, we had to do it from scratch. All right, which is a little bit more work. Now, we've also got a median. So we're going to go Q1, and then we're going to go Q2, and then we're going to go Q3, and then after that, an interquartile range. The mode is super easy in grouped data because it's the most frequent. Okay, and in this case, we're actually bimodal because we have the most frequent for 159 to 169.5 and for 169 179.5. So this is just as frequent as this, but we don't use the ranges, we use the midpoints to state the mode. So when we state our mode here, we would go 164.5, which is the midpoint of one of the groups, and then comma 174.5. Okay, but it's actually kind of an average between those two because of where they're located, but we just state them as two possible modes, and that's perfectly fine. Now, for the interquartile range, it's actually quite useful for us to actually do a cumulative frequency. I'll show you how that works. So I'm just going to go cumulative frequency. Okay, and that's what we're going to put here. All right, and of course we've got our frequency here, so hopefully you remember from our frequency how to get the cumulative frequency. So for our frequency here, we go equals, and we put in this value, no problem. For the next one, we actually put in our formula. We go, okay, it's going to be our new values for this group plus everybody below it. So new values for this group, and then we go plus, and then everybody below it is the cumulative frequency. So we go enter. Okay, and of course we just test it out. 2 plus 1 is 3. 6 plus 2 plus 1 we know is 9, so we'll test out our formula when we drag it. It should be a 9, and it is. 6 plus 6 plus 2 plus 1, which is for this grouping here, is going to be 12, 13, 14, 15. So it should be a 15, so when we drag the formula, we get a 15. So we're trusting it, we move all the way down, and we should finish up with a 20. Okay, now why and how is the cumulative frequency effective in us figuring out Q1, Q2, and Q3? Well, we'll start with the median. We've got 20 data values, okay? And there's a little formula that you can use. 1/2 times n plus 1, okay? If you use 1/2 times n plus 1, n is this number of data values that you have, 21 times 1/2 is 10.5. If it's 10.5, it means it lies between 10 and 11. So our median lies between 10 and 11. Well, the nice thing about this cumulative frequency is at the beginning of this is 0, and at the end of this is 1. At the beginning of this grouping is 2, and the end is 3. At the beginning of this grouping is 4, and the end is 9. So the cumulative frequency is actually the bottom part of each of these particular groupings. So this grouping ends with the 15th. This grouping ends with the 19th. This grouping ends with the 3rd. Okay, so we can figure out where the 10th is. If this ends with the 9th, then we know that the 10th is in here. If this ends in the 15th, then we also know the 11th is here. So this right here is where our median lies. Now, what do we use for the median value? Well, we scroll all the way over to the midpoint of that grouping. So our Q2 ends up being 174.5, okay, because it's in that grouping. Now you may ask, okay, well, how do I figure out where my Q1 is? Well, for Q1, it's 1/4 times this n plus 1. Okay, so 1/4 times 20 plus 1, or 21. A quarter of 21 is 5.5, or 5.5. It's actually exactly on 5. Quarter of 21, no, is 5.25. 5.25 is partway between 5 and 6. So where do we find our Q1? Between 5 and 6. Okay, so where is 5 and where is 6? Well, this one ends with 1. This one ends with 3. So 4, 5, 6, 7, 8, and 9 are in this grouping. So our 5th and our 6th are in this grouping. So what is our Q1? It's 164.5. And so for our Q1, we go 164.5. Finally, for our Q3, we look at this data set and we say to ourselves, okay, where is our Q3? Well, it's 3/4 times n plus 1, or 3/4 times 20 plus 1, or 3/4 times 21. Well, 3 times 21 is 63. 63 divided by 4 is going to be 15.75. So 15.75 is partway between 15 and 16. So where do we find our Q3? It's going to be between 15 and 16. So we have to find out where 15 is, and we have to find out where 16 is. Okay, so we look through here. This is all the way up to the 3rd. This is all the way up to the 9th. Oh, this is all the way up to the 15th. So our 15th is right on the edge of this grouping at 174.5. Our 16th is just at the beginning of this grouping. Okay, so we actually have two values. So it's actually between 174.5 and 184.5. So what do? You take these two values, you add them up, you divide by 2, or you take the halfway point. And halfway between 174.5 and 184.5, or halfway between the 15th and the 16th, is going to be 179.5. Okay, and you can go ahead and crunch those numbers if you want to. 174.5 plus 184.5, add it up, divide by 2, and you're going to get 179.5. So my interquartile range, quite easily, is going to be my Q3 minus my Q1. There it is. And there we have the interquartile range. Now, a little bit more work, a little bit more figuring. It's almost like it's doing it just from scratch. And in essence, you would do this exact same thing on a piece of paper if you wanted to. So this is exactly how to do the front part of your assignment that you have for your end unit sort of evaluation. Okay, so you can maybe use this for the front page of that work too if you want to figure that out. Anyway, I'm going to save this file for you guys so you have an example about how to do all of it. I'll space out the graphs for you so you can have a look at them. You can have a look at all the formulas that I use for all these stats and have a look at the videos. Okay, that's a long time to watch the videos, I know, but you're going to have a whole day on Monday or on Friday. I haven't decided yet on how to do this stuff. I'll post the videos and say that they could be helpful to you if you don't know what to do for your data, for your assignment that's due on Friday by 11:59 p.m. And both of those, of course, go in for your final marks. So hopefully this is all okay for you. Okay, it was a little bit of a whirlwind tour. So have a look, pause it, rewind it, look it over again, see what I've done, and hopefully it makes sense. Talk to you later.